No, Lulu! Miss Aronson needs that whipped cream for her pecan pie. You know you can't build ramps and slide into vats of whipped cream. I don't think this cat sitting job was such a good idea. Guess we have to take you back. Evie!
What happened? I was doing my physics homework.
Lulu built a ramp against going to the whipped cream.
I don't think this was such a good idea. Let's take her back to Miss Aronson.
Yeah.
I'll go start the car.
Okay.
Oh.
I forgot Lulu's treats. Here, take her. Oh my god, Lulu, are you okay?
I think we should take her back to Miss
Yeah,
Aronson
let's
now.
go.
Safe and sound. The horizontal or x position versus time graph is constant and linear because the velocity is constant throughout Lulu's path, which means there's no horizontal acceleration. The slope of the line is negative because Lulu is moving away from the origin. The vertical or y position versus time graph is an upside down parabola. The slope of the vertical position graph represents Lulu's velocity, which is decreasing in a positive direction during the first half of the arc because the force of gravity, negative 9.8 meters per second squared, is pulling down on her, and during the second half of her path, as she's on her way down, her velocity is increasing in a negative direction because, once again, the force of gravity is pulling her down. The vertical velocity is affected by the force of gravity, therefore it has the same slope as a free-falling object because a free-falling object also only has the force of gravity acting on it as it's falling. The difference between forces acting vertically and horizontally is that there's no force being applied to the object in the horizontal direction, so the velocity never changes and acceleration is always zero. The force of gravity is being applied vertically to the object, so it's always being pulled downward. This is why the acceleration is negative and why velocity during the second half of the parabolic path ends up being negative.
On our way to Miss Aronson's house, let's think of some other scenarios that could have happened if we didn't stop Lulu. So the first one is, let's imagine Lulu builds a cat launcher to launch herself to the bowl of whipped cream that is 4 meters away. So she launches herself at a 30-degree angle and is launched at an initial velocity of 5.3 meters per second. So we want to see if Lulu will be able to make it to the bowl of whipped cream. So, since we had the initial velocity, we can find the vertical velocity using the sine of 30 multiplied by the initial velocity, which gives us 4.54 meters per second. And since we know the initial velocity in the vertical direction, we know that the final velocity is equal and opposite to the initial velocity. And the acceleration in the vertical direction is negative 9.8 meters per second squared because negative 9.8 meters per second squared is a component of vertical velocity and vertical motion. So we can calculate how much time Lulu is going to take to reach the bowl by using the equation delta x equals vi plus 1/2 at squared. So by plugging in the values that we got, we get the time to be 0.94 seconds. In order to calculate the horizontal distance that Lulu is going to be traveling, we can use the time that we calculated from the vertical direction and use that time for the horizontal. But first we need to calculate the initial velocity in the horizontal direction. So we can use the adjacent over the hypotenuse, which is cosine of 30 times 5.3 meters per second, and that gives us 2.65 meters per second. And since there's zero acceleration, the velocity final is going to be the same as the velocity initial, which means velocity is constant, which means there's no acceleration. So the time is going to be the same as the vertical direction, which we established, and so we can use the equation delta x in the x direction equals 2.5 meters per second times 0.94 seconds and 1/2 0 the acceleration times the time, but the whole thing cancels out because of the 0. Then we can just solve for the distance, the horizontal distance, and we get 2.491 meters. So that means Lulu doesn't make it to the whipped cream. So the second scenario is involving Babs, who is Lulu's best friend. Babs wants to give Lulu a high five for her ability to create a cat launcher that unfortunately didn't work perfectly, but Babs still wants to give her an A for effort. So, in order to calculate whether they will be able to meet halfway so that Babs can give Lulu a high five, we need to calculate halfway in the vertical direction. So we can use the initial velocity that we calculated in the vertical direction from here by using sine of 30 degrees times 5.3, and then we can use that to put for the initial velocity, which is 4.54 meters per second. Since we're trying to calculate whether they will meet halfway between, we know that the final velocity right here is going to be 0 meters per second, and the acceleration is negative 9.8 meters per second squared. And then we know that the time is 0.46 seconds by calculating it from the equation right here, since we have acceleration, final velocity, and initial velocity. So what we did was we did 0 final velocity equals VI, which is 4.54 meters per second, and then minus 9.8 meters per second times time. And then by solving for time, we can calculate obviously the time that it takes for Lulu to go halfway, which is 0.46 seconds. And then we can use that time to plug it in for the equation to solve for the vertical displacement that Lulu is going to do. So we use the initial velocity times the time plus 1/2 acceleration, and then times the time squared. So by solving this quadratic, we get 1.05 meters. And since Babs is hanging 1 meter from the chandelier, we know that both cats will be able to high five each other.
Yay.
Yay. If Lulu decreases the angle of the kitty launcher and keeps all other variables the same, will she still be able to high five Babs? No, because by decreasing the angle, the vertical range decreases, while the horizontal range increases. This means that Lulu won't go high enough to reach Babs, but she might go far enough to reach the whipped cream, depending on the angle.
So you're gonna film me?
Lavarito.
Like, strap it.